You know, every single time you send an email, stream a movie, or even just browse a website, you are using a secret rulebook that makes the whole internet function. It's called the OSI model, and in this explainer, we're going to pull back the curtain and break down its 7 simple steps.
I mean, really, have you ever stopped to think about it? You hit send on your screen, and boom, it just appears on another screen halfway around the world, almost instantly. It feels like absolute magic, doesn't it? Well, it's not magic. It's actually an incredibly organized, step-by-step process.
Okay, the best way to wrap your head around the OSI model is to think of it like a super efficient global digital postal service. Every little piece of data, whether it's an email, a text, or even a single pixel from a photo, is treated like a package. It has to be prepared, addressed, shipped, and then delivered. And this model, it's the universal guidebook that every single device on the planet follows to get the job done. And here they are, the 7 steps of that journey. When you're sending something, you start at the top with layer 7 and work your way all the way down to layer 1. Then, on the other end, when someone receives it, the whole process just happens in reverse, from the bottom up. So let's start at the very top. All right, part 1, preparing the message. This first phase is all about getting your data packed up and ready for its big trip. These first 3 layers are what people often call the software layers, mostly because they deal directly with the apps running on your computer. Everything starts right here with you at layer 7, the application layer. This is your web browser, your email client, your messaging app, whatever you're using. In our postal service analogy, this is you actually writing the letter or picking the photo you want to send. This layer uses protocols you've probably heard of, like HTTP for websites, to get the whole process started. Next down is layer 6, the presentation layer. Think of this guy as a universal translator and a security guard, all rolled into one. It does a few critical things. It translates your data into a standard format that any computer can understand. It encrypts it for security, and it often compresses it to make it smaller. So it's basically putting your letter into a standard, secure envelope, written in a language everyone can read. Now, before your message can go anywhere, the 2 devices need to open up a line of communication. And that's the whole job of layer 5, the session layer. It creates a connection, keeps it stable for as long as you need it, and then closes it down properly when you're all done. It's kind of like a postal clerk opening a special service window just for you, making sure your conversation doesn't get interrupted. Okay, part 2, the global address system. Our message is written, it's translated, the line is open. Now we get to the really fun part, the logistics of actually getting this thing across the internet. So if you were trying to mail a 1,000-page book, you wouldn't just cram it into one giant awkward box, right? No, you'd send it in a few smaller, more manageable packages. Well, that's exactly what the transport layer does. It takes your data and chops it up into smaller chunks called segments. And crucially, it numbers each one so they can be put back together in the right order on the other side. Pretty smart. But wait, there's more. The transport layer also lets you choose your delivery style. For something really important like an email, you'll use TCP. Think of TCP as certified mail with delivery confirmation. It checks and double checks to make sure every single piece arrives safely. But for something like video streaming or online gaming, you might use UDP. That's more like a postcard. It's super fast, and if a few pixels get lost, who cares? The stream just keeps on rolling. Speed is more important than perfection. Now we get to layer 3, the network layer. This is the master logistician of our digital postal service. It's like the GPS for the entire internet. Its whole job is to look at the final destination and figure out the absolute best path for your data to take through the huge, messy web of networks that is the internet. This is where routers do their thing. So how does the network layer know where to send anything? Well, it adds the most critical piece of information yet, the IP address. This is the full global address of the destination computer. Just like a street address, city, and zip code on an envelope, the IP address tells the entire internet exactly where this little packet of data needs to end up. And yeah, this is what one looks like, just a string of numbers. But this simple-looking identifier is what allows routers all over the world to forward your data packet one step closer and closer to its final home. Okay, we have prepared the message, we've given it a global address, now we are down to the nitty-gritty. We're talking about the last mile of delivery, moving the data from one physical point to the very next, and that's handled by the bottom 2 layers. So if the network layer plans the whole cross-country trip, the data link layer is only worried about the very next stop.
Its job is to get the data packets safely and without errors from one device to the next one it's connected to, say from your computer to your Wi-Fi router. It's like making sure the mailbag gets from one post office to the next without a single letter falling out. So, if the IP address is the global street address for the building, the MAC address is like the specific name on the mailbox. It's a unique hardware ID that's burned right into your device. This local address is what makes sure the data gets from the router to your specific laptop and not your roommate's. At this point, our data packet gets wrapped in one final digital envelope. It's called a frame. This frame holds the local MAC addresses it needs for just the very next hop on its journey. This whole process of wrapping data inside other data, layer by layer, has a name, by the way. It's called encapsulation. And here we are. We've finally hit rock bottom. Layer 1, the physical layer. This is where all that carefully prepared and addressed data becomes, well, actual physical stuff. It takes those digital frames from layer 2 and turns them into electrical signals, pulses of light, or radio waves. We're talking about the raw ones and zeros that actually travel over the hardware. This layer is the physical infrastructure. It's the Ethernet cables, the fiber optic lines buried under the ocean, the Wi-Fi signals bouncing around in the air. In our postal service analogy, these are the actual trucks, planes, and roads that our digital postal service uses to physically move the mail from point A to point B. So, our data has zipped across the world as a series of electronic pulses. What happens when it finally arrives? Well, the entire process we just walked through happens all over again, but in perfect reverse order. Think of it like a set of nesting dolls. The receiving computer starts at the bottom and unpacks the data layer by layer. It starts with the physical signal, turns it back into data, unwraps the frame to find the packet, unwraps the packet to get the segments, and then reassembles everything. It keeps working its way all the way back up the stack, translating and decrypting until your friend's app gets the original complete photo. And you know, the real genius of the OSI model is simply that it's a universal standard. Because every device in the world, no matter who made it, agrees to follow these same 7 rules. A computer in Tokyo can talk flawlessly to a server in Brazil. It's an absolute masterpiece of digital teamwork. And that kind of leaves us with a final thought to chew on. Each layer depends completely on the one below it. So what happens if just one fails? If your physical cable is broken at layer 1, well, nothing else matters. If your IP address is wrong at layer 3, your data is just lost out in the void forever. It's this incredibly brilliant yet surprisingly fragile chain that holds our entire digital world together. And that's the OSI model in a nutshell. I hope this explainer helps you see the incredible hidden logic that's happening behind every